started talking about kind of naming alkanes and sort of process. So let's really talk about, again, kind of go over the process here and sort of the steps. So to do the IUPAC way of naming, it pretty much always starts with the longest continuous carbon chain. And once again, as we sort of saw in some of those examples that we did, it may not always be the straightest. So as we did a number of those, you do want to kind of check every option to try to find the longest continuous carbon chain. Once you do that, once again, it really should match one of the first 10 alkane names. And once again, that's really going to be sort of like the base of your name. So that's going to be really the base of the name that you go there with. Once you do that, as I did in some of those examples, sometimes it's good to highlight it, put a box around it, and that sort of visually you can see, okay, that is like the main part that I'm dealing with. And then everything else that's attached to it that is not part of that longest continuous carbon chain, those are what are referred to as groups. So as we talked about, if it is a carbon containing group, it is what is referred to as an alkyl group. And that basically is, again, related to the, on top of one of the first 10 alkane names. So those groups will also be related to the first 10 alkanes. Again, the major difference here is it will be missing one hydrogen, as we talked about, to allow it to really to connect in. So it'll be the first 10 alkane names missing a hydrogen. And again, that is what allows it to connect in. So as we saw there, if it's a one carbon group, instead of methane, it is what is known as a methyl group. If it's a 3 carbon group, instead of propyl, it is what is known as, instead of propane, is known as a propyl group. Once you have your longest continuous carbon chain, once you got all the groups sort of identified, the next thing that you want to do is number the longest carbon chain. And here the priority goes to the groups. And the goal here is to get the groups to the smallest number. So again, as we talked about, there's really, in most cases, 2 ways you can number it, kind of either left to right, right to left, one side to the other side, or the obviously other side to the first side. And again, the way you decide which way you should stick with is based on whichever one gives the groups the smallest number or set of numbers. So like the last one we did, we had 2 different groups, and there was 2 sets of numbers, like 2 and 4, right? And 4 and 6. And when you have that type of situation, you're really just looking at the first numbers and compared the 2 first numbers. So in that example we did at the end there was like a 2 for the first one, right? And a 4 for the next one. So the set of numbers that started with the 2 would be the smaller numbers. And it really is that simple. It's just simply whichever number is smaller. And that is the way that you would stick to numbering everybody that's attached to that particular compound. Once you do that, we're going to always go with the groups first, followed by the longest carbon chain. When we name it. We do those couple of things that we talked about. Whenever you have any type of transition between either a number and a letter, you need a dash between the 2. Also, if you have a letter going into a number, you also need a dash between the 2. So we put a dash between those 2. And if you happen to have 2 numbers that come back to back, you need a comma to separate out the two numbers. Any questions on that there? So let's take a look at one here and see what we end up with. Okay, everybody good? Yeah. All right, so let's try this here. Let's go with all right, so why don't you take a moment and see what you would come up for the name of this guy here. Okay, let's take a look, and this is a good example of something I forgot to put on the list. So let me add it here, and then we'll talk about how we apply it to what we just had there. Now, when we go to name the groups, it can occur like it should in this one here, that you might have actually more than one of the same group in the actual compound. So when you have more than one of the same group in the compound, we do use prefixes. And for example, di is 2, tri is 3, tetra is 4. So we do use these prefixes when we do have more than one of the same group in the compound. Now, it doesn't have to be on the same carbon, those groups, but anywhere on any carbons, if you have two of the same groups or 3 of the same groups, we incorporate these prefixes on top of the names. So let's see how that works in this example, which actually is a good example of all that, I think. So first off, we do want to start with our longest carbon chain, and that should be in this case, it should be 3 in this case, right? And you could do it really multiple ways. You could just go straight across, right, which gives you 3. You could also go straight and then go up, right, which would give you 3. You could also go straight and then go down, which will give you 3. Just so you know, no matter which way you choose the 3 in this case, it should end up with the same name. So it doesn't necessarily have to take the straightest one. Sometimes though, if you do take the straightest one, it's a little bit easier maybe to see everything else, but it should come out the same name regardless of, you know, which way you took it, the longest carbon chain. So really, we were halfway home here to our name. The longest carbon chain here is 3. 3 carbons is propane, right? So that really is sort of the base of the name. At this point, we have a couple of groups that are hanging off of it. We have a group that is here, which is a 1 carbon group, and that would be a methyl group. We also have another 1 carbon group down here, which would also be a methyl group based off of methane. Again, dropping the ANE and putting the YL. Now, in this particular case, what I just added would come into play. In this particular compound, we have 2 of the same groups. So those guys would then be known as dimethyl. The di because there's 2 methyl groups. Again, not on the same carbon because they're on the same carbon, but just because there's 2 groups in the compound. So again, they could be on different carbons and they would still be di. But because there are 2 of the same groups, you do need to put the prefix in front of the group name there. Any questions on that there? Now, what's left here is to really number our chain. So we could go left to right or right to left. If we go left to right, that's carbon 1, that's carbon 2, and that's carbon 3. If we go right to left, that is carbon 1, that is carbon 2, that is carbon 3. Doesn't matter in this particular case which way we go. It doesn't. Both of the groups end up basically 2. This one is at carbon number 2. That would, of course, give us 2, 2 here, which would be a good one. So thank you. It would be 2, both of those methyl groups are hanging out at carbon number 2 in this case. So once again here with the correct numbers there, we do a comma between 2 numbers and we do a dash between a number and a letter. And in this case, Once again, the die is not because they happen to be on the same carbon, but it's because they're in the same compound. So that's why the die is there. By the way, if you do have, say, like a situation like this and some other group attached, when you do the alphabetical order, you actually ignore the prefix. So you would still be looking at the M here. If you had something else, like I say, you had a bromine in there as well, the bromine would come first, and then this guy would come second. So when you do alphabetical order for the groups, you do ignore any prefixes that are there. You go with basically the first letter of the name there. Any questions on that? So let's try one of these here. Let's try another one. Let's do a little line structure, see how we do. Why not? Looks like fun. I'm just gonna put dots. Don't usually put dots, but everywhere there's a dot here is a carbon. And by the way, since there's nothing written at the end of these lines, these are also carbons there as well. So the longest continuous carbon chain really should come right about there. And that is 1, 2, 3, 4, 5, 6, and 7 carbons, which means the base of this name, once again, is going to be heptane. In this case, our two lonely lines there that have nothing drawn at the end of them, these are actually going to be our groups, right? And once again, because there's nothing written at the end of them, it's assumed that there is a carbon, and then there actually should be 3 hydrogens there because there's one line coming into it, right? And that means that that is really a methyl group, right? And this guy is a methyl group. So in line structure, if you got a lonely line that goes nowhere and stops and nothing's at the end of it, it's a methyl group that's just hanging out there. It's basically at the end of that line, you have CH3 hanging out there at the end of it. So that means what's left here is we do need to do a little bit of numbering, and you could probably see it. But again, if we go right to left in this case, that would be carbon 1, that would be carbon 2, that would be carbon 3, that would be carbon 4, that would be carbon 5, carbon 6, and carbon 7. Obviously, our other option would be to go the other way, this would be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. Going in the blue direction, we have groups at carbons 4 and 6. Going in the red direction, we have groups at carbon number 2 and 4. The correct direction, the number would then be, the smaller number is 2. So we would want a number in the red direction here would be the correct numbering. That means I'm going to try this again with the counting. That is carbon number 2 there for the methyl, and that is carbon number 4 there for that methyl. Yeah. Because there is 2 methyl groups in this compound, we should now call that not just methyl, but we should call it dimethyl, right? Just like we had before. So we'll start with our number, which is 2, 4 dash dimethyl, which gives the location of where each of those methyl groups are located. And the rest of the name will just be here, our heptane. Any questions on that name there? Yeah. Okay, so looking at the next one, longest carbon chain here should be 6 in this case, coming straight through, actually, right there. So longest carbon chain is 6, and that means that the base of this guy's name is going to be hexane. At this point, we have one group here, which is going to be a 1 carbon group, which is a methyl group. We have this guy, which is one of those halogens. So that is chlorine, which becomes a chloral group. Yeah. Any questions on that then? Now, again, you can probably see which way you should number, but again, if we go right to left, 1, 2, 3, 4, 5, 6. If we go the other way there, 1, 2, 3, 4, 5, and 6. we should number in this case right to left, right? So we should be going this way. That gives our group carbon number 2 and carbon number 3 versus in the red direction, carbon number 4 and carbon number 5, right? So this would be the incorrect way to number that. Yeah. That means going in the proper direction, which is right to left in this case, we have our methyl group. Once again, numbers here, that is 3. And our chloro group here, which again is 2 in this case. So again, we got to stick with the same numbering for everybody once we choose which way we're going. Alphabetical, our chloral should come first. So this would be 2-chloral dash our next group, which is our methyl group. And then finally, hexane. So 2-chloral dash 3 methyl hexane. Question on that naming there. Okay. So another thing about naming is if you do have an alkane that is sort of a ring structure, we basically name it the same way. You name it based on the number of carbons, but the additional thing that you put in there is cyclo in front of it. So for example, if we had this guy here, which is 3 carbons in a row, that is propane. If propane decides to close in on each other in a ring structure, it will look like a triangle. It has 1 carbon, 2 carbons, and 3 carbons. So it is still propane, but we put cyclo in front of it, and this becomes cyclopropane, basically. Now, if I had, by the way, the condensed formula would look something like this. A lot of the cycloalkanes are geometrical shapes, like a triangle. What would a square be? I guess that's sort of a squarish. Square here has 1, 2, 3, 4 carbons. 4 carbons is butane. Because it's a ring structure, it becomes cyclobutane. What would this guy's name be? How many carbons does it have? It does have 6, right? 1, 2, 3, 4, 5, 6. 6 carbons is hexane. Because it's a ring type structure, it is cyclohexane. By the way, the cycloalkanes, which is what these guys are called, have 2 less hydrogens than the straight chain alkane. They have 2 less hydrogens because the 2 ends come together and they got to sacrifice a hydrogen each to close up into a ring structure. What happens if I got me a methyl group hanging off of that cyclopropane? What would it be called? This would then be called, that group is a methyl. This would be methyl cyclopropane. You do not need a number in this situation because it's assumed that wherever that group is attached is carbon number 1, because there's just 1 group attached. If you have more than 1 group attached, then you need numbers. So for example, if we took our cyclopropane here and we did, we'll do I'll throw a chlorine over here. We throw a chlorine off this end of it. Now I have 2 groups, right? I have a chlorine group and a methyl group. I do need numbers. Which one should get the smaller number? The chlorine or the methyl? We put our groups together in what type of order? Right, so which one should get the smaller number? The chlorine, right? The chloral group. So that is where we actually would start numbering in this case. So the chlorine group would be carbon 1. And if I go to the left, that then would be carbon 2. And in this case, this guy would be called 1-chloral, 2-methyl cyclopropane. So when you have a cycloalkane like these guys, and you have multiple groups attached, you do need to number them. And again, you want to number really starting whichever one would come first in the name alphabetically. And then you could go clockwise or counterclockwise, whichever way gives the next guy the smaller number. If you have just one group attached in a cycloalkane, there's no need for the number because it's assumed wherever that thing is sitting will always be carbon number 1. So that's why originally we just called it methyl cyclopropane, because there was only one group attached. So that would be carbon number 1. So again, if I put a chlorine here, this then would be chloral cyclohexane. Yeah, again, you do not need a number because it's the only guy attached. Yeah, so this guy then would be, if we threw it in there, chloral cyclohexane. Now if I put another chlorine here, this then would be, it would be dichloral cyclohexane, but because there's more than one group, we need numbers, even though it's the same guy. So in this case, you could actually start at either chlorine. I'm going to start at this chlorine here and call this number 1, right? If I went counterclockwise, that would be 2, 3, 4, and 5, which would give me numberings of 1 and 5. If I started at that same carbon and went clockwise, that'd be 1, 2, and 3. Which way should I go? I should go clockwise. It gives me those groups at 1 and 3, which we would need to put into the name here. And that would be 1, 3 dichloral cyclohexane. So once again, when you have more than one group attached in a ring structure like this, these cycloalkanes, you do need to give the numbers. And you start with whichever one should come first in the name alphabetically. And then again, as we see in this one, if it's shorter going clockwise, go clockwise to the next guy. If it's shorter to go counterclockwise around the ring, you could go that way. Again, it is always the smallest numbers is what you're shooting for when you are numbering these things. Question on that there. All right, so we did some names of some structures. Let's talk about, frankly, the easier thing of it all, which is if you have a name and you need to draw it. So let's say we were given a name like randomly here, 2-chloral 4-ethyl. Why not go with octane? I'm going to regret it in a second, but I'll go with octane. All right, so that is 2-chloral 4-ethyl octane, and we want to draw this thing, right? So whenever you have the name and you want to draw it, even though it looks like a crazy name and it's going to take forever to draw, it's really the simplest of everything that you do. So whenever you have the name and you want to draw it, you always start backwards and work your way that way. So if we start backwards, what that gives us, right, as we've been naming, is the base of the name, right? It gives us the longest carbon chain. So when I see octane, that means I should lay up how many carbons? 8, which is why I'm regretting it right at this point. I should have chosen a smaller name, but all right, we'll go with 8. So really all I'm going to lay up to start with is just the carbons, just the 8 carbons. So 1, 2, 3, 4, 5, 6, 7, and 8. Whew, good thing I didn't go with 9. All right. So frankly, I could like cross that part of the name. It is done. Yeah, I got the octane part out of the way. What is left is now our groups, right? And what that means is at carbon number 2, there is a chlorine, right? And at carbon number 4, there is a ethyl group. The beauty of it is, since you are drawing, you could number it whichever way you want. You could go left to right as 1 through 8, or you could go right to left. But for me, I'm going to choose that over here. I'm just going to put a little 1 there. That's going to be my carbon number 1, which means for me, I'm going 1, 2, 3, all the way to 8, coming this way, right? You could again choose the other one as carbon number 1 and go the other way. It doesn't matter because you're drawing it. which means, frankly, now I just need to write what it says. So at carbon number 4, which for me would be 1, 2, 3, and 4, there is a ethyl group, and that ethyl group is based off of ethane, which is a 2-carbon group. So at carbon number 4, I do a 2-carbon group there. And that is done, right? That means at carbon number 2, there is a chlorine sitting there. Again, for me, carbon number 2 would be here, which I would put a chlorine, and I am done. Now, if we are drawing the condensed formula, which we'll draw the condensed formula here, I'll get rid of these numbers. All that is left to put on there are hydrogens. And we need to put enough hydrogens that each carbon ends up with how many bonds? 4. So if we start here on the right-hand side end, this guy has 1 line coming in, which means he needs 3 hydrogens, right? The carbon next to it has 1 line on the right and 1 line coming in on the left, which is 2, which means this guy needs 2 hydrogens. Guy next to him, same deal, 1 on the right, 1 on the left, which is 2, which means it needs 2 hydrogens. This guy has a line on the right and 1 on the left, which is 2. This guy needs 2 hydrogens. The next carbon needs how many hydrogens? It actually needs only 1. It's got 3 lines coming in, which means it needs just 1 more to get to 4. Guy next to it here, 1 on the right, 1 on the left, which is 2, which means this guy needs 2 hydrogens. This carbon next to it needs how many? 1, 2, 3, which means just needs 1. Guy at the end has only 1 line coming to it, which means it needs 3. Even our groups, if you weren't sure how to put the hydrogens in, this guy right here on the group has 1 line coming in and 2, which means it needs 2. And the guy at the end of our group needs 3. We are done. Yes. So it's really kind of the easiest of all of it because frankly, you have the name and it tells you what to draw. So you always want to work backwards when you have the name. Start with just the carbons, fill in all the groups, and then fill in all the hydrogens to get everybody to 4. Any questions on that one there? Why don't you try one here? Why don't we do let's do 2-bromyl, 3-chloryl butane. All right, draw the condensed formula for it, which is what we just did. So again, start backwards and work your way to the other side. Okay, let's take a look. So once again, always start from the back of the name. So this part tells us basically how many carbons to put out. So butane is 4. So we should start with 4. And again, we're just going to start with the carbons. That pretty much takes care of that part. Once again, we could decide which way we want a number. I am again going to call this for me carbon number 1, which means to my right there, carbon number 2, carbon number 3, and carbon number 4. We could see that at carbon number 3, there should be a chlorine, which means for me, carbon number 3 would be right about there, and we should have a chlorine attached. For me, carbon number 2, which would be right here, will have a bromine attached. And at this point, we're out of name, so that means we're just going to fill in everything else as hydrogens. This guy on the right has 1 line coming in, which means it needs 3 hydrogens. The guy next to it has 1 line, 2 lines, and 3 lines, which means it needs 1 more to fill it up. Also, the guy next to it has 1 line, 2 lines, and 3 lines, which means it needs 1 more hydrogen. And our guy at the end here has 1 line, which means it needs 3. Yeah. There you go. Yeah. Any questions on that? Yeah. The easier the 3 things that you do there. Yeah. And again, if you had something that was, say, cyclopropane or something like that, you would again just draw it in a ring structure when you start out with your carbons, and then you can attach everything else. Question on how to go from name to formula. Obviously, if we're doing expanded structural formula, it would look exactly the same, except you just draw out the bonds to the hydrogens, basically. Yeah. Any questions on any of that stuff? Hopefully it's becoming a little bit more clearer, I hope. Yes, we'll do more examples.